Now this exam question is clearly a part B question on financial maths. And like even if we just scan down through it at the start, this would have been one of the more difficult questions in this paper this year. Okay, so it's 55 marks, and like even just by glancing at the stuff, even and this table, in fact, would have caught a lot of people this year, right? But we'll go through that in a second. Now, if you look at the question, the first thing you always need to figure out is what kind of question is it? And clearly we can see this is a loan question, right? So a loan or a mortgage uses the same formula. But there's four types of financial questions that you can possibly ask, right? So there's your two regular savings ones. There's this one, which is a pensions one. And there's this one then, which is your loans or your mortgages. Okay, now there's a formula for each of these ones. Okay, now the good news is that for the loan and mortgage ones, this is the only one that's actually available in your log tables. Okay, so you can see there, if we zoom in on this, this is your amortization, mortgage and loan. That's available in your log tables. So that's the good news. And the bad news is that in this case, even though we're given this in our log tables, in this question they actually ask us to show how this formula is derived. Now, of all the formulas, this is the hardest one to derive, and the individual steps are manageable enough, but there's just so much of it, as you'll see in a second. Now, it's kind of important really that you do understand how these formulas work, and in particular how loans work. Okay, now just a brief explanation. This is the way I kind of do explain it is, right, you get a loan of P euro, that's your present value, right? So when you go to the bank in the morning and get your 10,000 euro, for example, that's what it's worth, 10,000 euro. And what you want then is you want to repay it every month, and you want to repay a fixed amount of A. Okay, now that's your kind of future value. Okay, we'll talk about that now in a second. So you're paying off your 100 euro a month, we'll say. But the problem is the second that you take out this loan, you're being charged interest, right? So that first month, you're still paying back your 100 euro, but a tiny proportion of that is going to be interest. Okay, so this red part is actually the only part that's going to repay the loan. Right? Now, the even bigger problem then is the second month you have a small bit more interest, and the third month that amount of interest is bigger again, right? So that by the final month you're still paying back your 100 euro, but almost half of that, well, depending how long you're taking out the loan for, is being actually paid to interest, and this is the only thing that's contributing to your loan. Okay, so and this is the kind of technical bit here. Now we need to figure out how much are these red bits worth. Right, and that's where your present value formula comes from. And in all of these questions, you're coming up with a geometric series, right? And the geometric series in this case is this. Now, I could go on and on forever about explaining why is that red section here represented by this fraction here. If you are a small bit confused by it, look at your log tables. We're looking for the present value, so it's this formula that we're looking for. Right, so this red section is worth that amount. This red section is worth this amount. And this red section here is worth this, and all of these, if we add up all of these red sections, we end up with the loan amount. So that's where that geometric series comes from. All right, so now we want to rearrange this, and we want to put it into our geometric series formula. And look, we're looking for what A is, what R is, and what N is. Now A is the easy one. A is your first term, which is straightforward enough, and R then is your common ratio. So if I divide this by this, I'm going to get 1 over 1 plus I, because the A's will cancel and this square will cancel with one of these, so that's why we're left with that, right? So like it's a routine kind of question. Like the more you do these, the more you kind of understand it. And finally, N then is the amount of months. Now in our formula, N, it's T. Okay, now they're kind of interchangeable really, but so we'll say N is T. So now we're just simply subbing these values in there, and we get this. Okay, now technically that'll work fine, but we now need to go about the process of rearranging this to turn it into this. Okay, so now the geometric series kind of part of it is done. Your understanding of loans part is done, but unfortunately now is the hard part where it's all algebra from now on. Okay, so here we go. Now what we're aiming to do in what we're trying to prove, it's A in terms of P, whereas at the moment what we have is P in terms of A. Okay, so we're just trying to rearrange this so that effectively that's what we're trying to do. We're trying to rearrange it so that A is on its own. Okay, now one bit of advice I'd give you is that expressing fractions as a single fraction is a major skill in this case, right? And like our first step here is changing the denominator here so that it's as a single fraction. So if you don't know how to do that, that is one of the most underrated skills in Leaving Cert maths. Okay, so just make absolute sure that you know that process there. And the reason it's so handy here is because now the 1 plus I and this 1 plus I will actually cancel. Okay, and 1 minus 1 will cancel here. So we're just left with I underneath the line. All right. Now my next step here would be I'm just going to get I and the A, and just going to separate them out slightly. right, like that. And our next step now again is to express this as a single fraction, right? So again, make sure that you know that skill, you know how to turn that into that without even thinking. Now, there are a few other ways you could do this, right? You could get closer to getting A on its own. You could start here. But the reason I do it this way is because what we have here is actually our pensions formula, right? So if you wanted to figure out a formula for your pensions, or if you're ever asked to derive that, that's what we have here. Okay, so sometimes it might be a good idea just to learn it this way. So if it's a pensions formula we're looking for, now we can stop. But now we just want to now turn this in, get A in terms of P. So our final step is easy enough. It's just a bit of cross multiplication. So multiply across here by I. And then another bit of cross multiplication. So multiply this out here and multiply this below the line, right? So just cross multiplication here. So we have A on its own, and that's pretty much what we were looking for. We can just rearrange it then slightly so that it looks exactly what we're looking for, and there's our formula done, right? So a lot in it, a lot of steps. It's just a matter of going and practicing it. Now, interestingly, look, this is actually what goes up in the marking scheme, right? So whatever way you go about doing it, you have to have the geometric sequence at the start. You have to show that you substituted into the geometric sequence. And like, if you get that far, if you do that far, this was only worth 5 marks this year. And if you just went that far, that's 4 marks already, all right, which is a bit sad, really. So after that, then whatever you do after that, you know, you just make sure that you have these steps. And I don't think you can do this in 3 steps. Like, they're skipping a lot of steps here. It's just these are the lines that they're looking out for you to get full marks. Okay, so don't just assume you can do it in 3 steps. So for the main body of this question then, so for B onwards, a big mistake people made in this question is they actually overcomplicated it, right? So it is quite a complex question, but they do kind of guide you into the question just with the way the questions are phrased. Like this question here, so the loan is worth €5,000, and they say that one option is by paying 2.5% of the loan back every month. So what is the fixed monthly repayment? Like, it's as simple as this, 5,000 by 2.5%, right? So that's what you're paying off every month. Right, now this part 2 should be, everybody should know this straight away when you see this. This is converting an annual percentage rate to a monthly percentage rate, and like, without even thinking, you should know how to do this. It comes up almost every year, and the process is the exact same. This formula isn't in your log tables, all right, but like, you just need to go and learn off this process. We want to know what interest rate compounded 12 times will be equivalent to an interest rate compounded once. Okay, now if you don't know what that means, or if you don't follow that, you just need to go back and learn off this process and make sure you understand what's R, what's I. In this case, R is going to be 0.2175. So small bit of algebra, get the 12th root of this, subtract 1. So the monthly interest rate that corresponds to an annual interest rate of 21.75% is 1.65%. Okay, there's no excuse for not understanding this. It comes up almost every year. Now this is the interesting part then down here. So this is how loans work, and it's actually a great question for, you know, getting you to understand how loans work. So the fixed monthly payment is going to be 125 each month, right? Now the problem is that the interest rate is 1.65%, and that's 1.65% of what you owe at the start of that month, right? So at the very first month, we owe €5,000, so it's 1.65%, so that's €82.50. So the sad thing is that of the €125 that we pay back that first month, €82.50 is actually the loan, is interest. So this is all we're paying off the loan in that first month, right? So that's how much that loan is worth at the end of the first month, right? But at the start of the kind of good news then is at the start of the second month, we're only paying 1.65% of this balance, right? So this is how much we're paying off. So you can see it's slightly less interest in this case. So therefore, there's slightly more being contributed to pay off the loan. Right, so we reduce this now by this amount, okay? And in the third month then, it's going to be 1.65% of this balance, which is this, which again is slightly less interest to be paid again. So this is how much we're contributing to paying off the loan. So this is what the balance is on that month, and that continues then on until the entire loan is paid off. Okay, so now we're actually asked to use the formula now in this case. So we want to now use the formula to figure out how long it would take to pay off the credit card. And like, it's this formula that we're using. And once you've established that it is this formula, the next thing we need to figure out is what are we actually trying to find, which variable, and it's how long it will take. So it's t that we're looking for, right? And this is one of the more harder types of questions to be asked in relation to this formula, because we have A, we know how much the monthly repayments are. We have P, we know how much the loan is worth. We have I, we have the interest rate, and we're looking for T. Okay, and this is quite tricky algebra to actually work out, right? So when we sub into our formula, it looks like this, right? It looks complicated enough, but not too bad really. And now we just need to rearrange this so t is on its own. Okay, so how do we do that? Well, look, we'll just get rid of the 5,000 first. Now I do that by simply just multiplying the 5,000 in here by that, right? So there are a few ways you can simplify that, but after that, it's impossible to simplify this any further. Okay, now this is where I use a technique called substitution. Okay, and it usually it's very difficult to see where this technique comes in. It's not really covered in a lot of the books, but what I do is anytime I'm dealing with certain indices like this, or sometimes surds as well, where there's something complicated in there that I want to get on its own, I just replace the complicated part with y. Right, so instead of saying all of this in here, I now come up with this equation, right, where there's y in here, and now I just want to get y in its own, which is actually a lot easier than it looks. So if I cross multiply here, multiply out my brackets, just do a bit of balancing, I end up getting y on its own like that. So y is equal to 50 over 17 when I divide across by this. So now I reintroduce the indice again. So instead of saying y is equal to this, I say 1.06165 to the power t is equal to that. And now I just go and solve this equation, right? So I'm combining these two equations to get this, right? So now another step. This is one of those things that a lot of students shiver when they hear, how do I solve an indice equation? Well, I use logs, okay? So just the way I say it is this is our base number here. So log in base of that, of this, equals t. Right, now if that doesn't make any sense to you, you just need to go back and learn your logs. Right, they come up in some shape or form most years, so just make sure you're comfortable with solving things like that. So, and the beauty of it now is that this goes straight into your calculator and it comes out as 65.92. So what does that translate as? So if you're paying off €125 a month to pay off a €5,000 loan, it'll be paid off in approximately 66 months. Now when you get to part 5, it looks as if we have to do nearly the exact same thing again. Right, but don't worry, it is the same formula, right? It's what he's after doing now is he's after getting a loan to pay off the loan, if you know what I mean. So, but the good news is that we're now using this formula for what it was designed for, right? We're looking for the amount, the repayment. We have the total amount, so we're just going to be subbing into the formula. The only problem is we don't actually have the interest rate. We have an annual interest rate, whereas he's paying it off weekly. So we need to convert this now from an annual rate to a weekly rate. Okay, now once you spot, like it's only the top students really will spot that. Okay, but once you do spot it, the calculation is easy enough. We want to know what rate converted 52 times, because 52 weeks in the year is the same as being converted once. That's what that translates as, but the actual calculation is easy enough. We're going to get the 52nd root of this number, which is a thing. And once you get that, it comes out as this. Now, I know now I should get I on its own here and get rid of that 1, but I'm just going to leave it like this, right? Because if you look at the formula, it's 1 plus I is what we're looking for anyway. So when I sub into the formula now, I'm just going to sub in 1.00, all of that in there. Okay, now once you have this done, then you can literally type that into your calculator. Now if I were you, I'd be careful with it. Maybe just do the fraction first and then multiply by 5,000, and it comes out as that. Right, so that means he's going to be paying €36.16 per week to pay off this loan. Okay, now remember we were saying he's paying off a loan. He got out a loan to pay off a loan, right? So why is he doing this, right? Surely that doesn't make any sense. And the answer to that is in this question down here, right? So how much will he save by doing this? So why didn't he just pay off the credit card company? Why did he get a new loan? Well, if you look at how much he actually ends up paying the credit card company if he paid it off that way, right? He was paying €125 for 66 months. Right, so that ends up paying 8,250. Right, so for a €5,000 loan, he'd end up paying up that much. Whereas for the credit union, he's paying €36.16 for 156 weeks, which only comes out as that much. Okay, so you can see that he's actually saving a huge amount by going with the credit union as opposed to the credit card company. And how much exactly is €2,609 he's saving? Okay, so it's just an interesting, like this is a brilliant question, as I said, for understanding how loans work.